Okay, so the first thing I need to do here is convert this into an improper fraction, which becomes 59 over 5. Then I do the division. 59, give myself plenty of space, and I'm going to be dividing that by 5. There, put the decimal point at the end of the number and in the same place in the answer, and tack on some zeros in case I need them. Okay, let's proceed. How many 5s are in 5? Well, the answer is 1. And I've got no remainder, so there's nothing to add on to the 9. How many 5s are in 9? Well, again, it's 1. And this time, we've got a remainder of 4, which gets carried on to the next digit. How many 5s are in 40? The answer is 8. I've got no remainder left over to take on to the next 0, and so I'm done. So this one is 11.8. Now for 1/8, it's already a fraction. So I don't need to do any conversion, I just go straight to the division. So we're going to do 1, and we're going to divide that by 8. So again, decimal point, some zeros in case I need them, and let's get on with it. How many 8s are in 1? None. I've got 1 left over, so I take that over to the next digit, and now I've got a 10. How many 8s are in 10? 1. Remainder of 2. Now I've got a 20 here. How many 8s are in 20? 2. 2 8s are 16, so I've got a remainder of 4. Now I've got a 40 here. How many 8s are in 40? The answer is 5. And I've got no remainder, so there's nothing to carry on to the next 0. That means that I'm done. So I've got 0.125. 2/3 now. It's already in fraction form, so no conversion necessary there. I'm just going to go straight to the division. So we're going to take 2, and we're going to divide it by 3. Decimal point, stack on some zeros, and then get to work. So, how many 3s are in 2? Well, there aren't any. So we've got 2 left over. We take that over to the next digit, and now I've got 20. How many 3s are in 20? 6 3s are 18. If I take the 18 away, I've got a remainder of 2. Now, how many 3s are in 20? It's 6 again, with a remainder of 2. How many 3s are in 20? 6 again, with a remainder of 2. How many 3s are in 20? 6 again, with a remainder of 2. And this is just going to go on forever. So I can write this in a couple of ways. I can write it as 0.6666666 and just spend the rest of my life writing down 6s. Or I can write 0.6 and put a little dot above it, which means that that digit, or that part of the answer, keeps repeating. I think I'll do that. 0.6 recurring. There. And lucky last, we've got 1 4/7. So first thing I need to do is convert that to an improper fraction. There. And then I'm going to get on with the division. So I'm dividing 11 by 7. Now I've left this one for last because I know that I'm going to need a lot of zeros here. So I've got a nice long line there. Long line, I should say. All right, let's see how we go. Now, how many 7s are in 1? None. Carry the 1. How many 7s are in 11? 1, with a remainder of 4. This is now 40. How many 7s are in 40? Well, 7 5s are 35, which gives us a remainder of 5. How many 7s are in 50? 7 7s are 49, with a remainder of 1. How many 7s are in 10? 1, with a remainder of 3. How many 7s are in 30? 7 4s are 28, with a remainder of 2. How many 7s are in 20? That'd be 2, with a remainder of 6. How many 7s are in 60? 7 8s are 56, with a remainder of 4. How many 7s are in 40? 7 5s are 35, with a remainder of 5. How many 7s are in 50? That's 7 with a remainder of 1. But you can see here that I've got a repeating pattern in the remainders and therefore in the numbers up the top. So as soon as I've identified the repeating pattern, I can stop. Now again, I could spend the rest of my life writing out this pattern of 571428, 571428, and so on indefinitely. Or I can write the answer 571428, and since this is the section that repeats here, I can stretch that dot to cover the whole thing.